Hi, my name is Zigar and this is a quick walkthrough of my closest pair of points project. So here I implemented both brute force and divide and conquer algorithm to find the closest pair among a set of 2D points. There's this first brute force function, and in this approach it simply checks the distance between every possible pair of points using two nested loops. It keeps track of the minimum distance found and the indices of the closest point. This method has a time complexity of big O of n square and works best for the smaller distances. Then here there are two different functions, one is merge sort and other is merge. So to prepare for the divide and conquer method, I created custom merge sort algorithm. This sorts the array of points based on their x coordinates. The merge function combines two sorted halves into a single sorted array. Sorting is a crucial because it allows the divide and conquer step to operate efficiently and achieves a much better overall complexity big O of and log n. And then there's this function called closest pair recursive. The closest pair recursive function splits the point into right and left two halves, recursively find the closest pairs in both halves, and checks across the split using a small vertical strip. For small subarray, it switches back to the brute force method. I also generated a random test points and verified that both algorithms correctly find the closest pair with matching result. Overall, brute force method is simple but slow, while divide and conquer is much faster and scalable for large data sets. If I run my project, then here you can see the brute force and divide and conquer, both the algorithms provide the same distances, even though the time taken by both the algorithms is way more different than each other. And then there's this result.txt file in which I have stored both brute force algorithm and divide and conquer algorithms average running time. And next, here I have implemented three different algorithms. In the first graph you can see brute force curve growing much faster compared to the divide and conquer algorithm. Then there is second and third graph which compares empirical data to theoretical predictions and showing that measured time closely matches the expected growth rates. This is more from my side.